Hello, my name is Jordan Williams, and this video demonstration will cover the inner workings of a thunderstorm and should result in the viewer being able to identify the risks and assess the hazards of a thunderstorm. This video will cover the types, stages, and hazards of a thunderstorm, as well as how to avoid and prepare for one. To start, a thunderstorm is a local storm invariably produced by a cumulonimbus cloud and always accompanied by lightning and thunder, usually with strong gusts of wind, heavy rain, and sometimes hail. Thunderstorms act as barriers to air traffic because they are usually too tall to fly over, too dangerous to fly through or under, and can be difficult to circumnavigate. Necessary ingredients for thunderstorm cell formation. Most processes require a few fundamental elements to occur before they begin, and thunderstorms are no exception. Thunderstorm cell formations require three ingredients. These are sufficient water vapor, unstable air, and a lifting mechanism. Sufficient water vapor is commonly measured using dew point, and this must be present in order to produce unstable air. All showers and thunderstorms form in an air mass that is classified as conditionally unstable. Another factor that is needed for unstable air is the lifting mechanism. Lifting mechanisms include converging winds around surface lows and troughs, fronts, upslope flow dry lines, outflow boundaries generated by prior storms, and a local wind, such as a sea breeze. Thunderstorm cell life cycle. A thunderstorm cell is a convective cell of a cumulonimbus cloud containing lightning and thunder. It undergoes three distinct stages during its life cycle, with a total life cycle typically being about 30 minutes. The first stage is the towering cumulus stage. The distinguishable feature of the towering cumulus stage is a strong convective updraft. The updraft is a bubble of warm, rising air concentrated near the top of the cloud, which leaves a cloudy trail in its wake, and updraft speeds are capable of exceeding 3,000 feet per minute. The next stage is the mature stage, and the cell transitions to this stage when precipitation reaches the surface. Precipitation descends through the cloud and drags the adjacent air downward, creating a strong downdraft alongside the updraft. Cumulonimbus tops frequently penetrate into the lower stratosphere as an overshooting top, where strong winds aloft distort the cloud top into an anvil shape. It's important to note that the weather hazards reach peak intensity toward the end of this stage. The final stage is the dissipating stage, which is marked by a strong downdraft embedded within the area of precipitation. During this stage, the updraft motion is slowed by a great degree, resulting in the cutting off of the moisture supply that was lifted through the updraft. Precipitation tapers off, and the convective cloud gradually vaporizes from below. Thunderstorm types. Thunderstorms come in various types, with the three principal types being single cell, multicell, and supercell. A single cell consists of only one cell, and its life cycle was covered previously. This type can be circumnavigated by pilots easily, but the risks of this type come at night or when embedded in other clouds. The next type is the multicell, which tends to be highly more common than single cell. Multicell thunderstorms are divided into two categories as well: multicell cluster and multicell line thunderstorms. A multicell cluster thunderstorm consists of a cluster of cells at various stages of their life cycle. With an organized multicell cluster, as the first cell matures, it is carried downwind and a new cell forms upwind to take its place. Due to this process, multicell clusters may have a lifetime of several hours or more, and will continue to form as long as the three crucial ingredients exist. These ingredients were water vapor, unstable air, and lifting motion. It's extremely tough to circumnavigate multicell clusters due to their size and persistence, which of course makes these storms dangerous. Thunderstorms will also tend to form in a line that can extend laterally for hundreds of miles. These lines are the multicell line thunderstorms, which are also known as squall lines. These new cells continuously reform at the leading edge of the system with rain and sometimes hail, following behind which are risks we will cover later. The line can persist for many hours or more as long as the three ingredients continue to exist, which allows these thunderstorms to last for a significant amount of time. These squall lines are the thunderstorm type which present the most trouble for an air traffic, and it's usually something no aviator should try to circumnavigate, with about 25% of all US tornadoes spawning from squall lines. Lastly, are supercell thunderstorms. Alright, supercell storms. This thunderstorm is an often dangerous convective storm that consists primarily of a single steady rotating updraft that persists for an extended period of time. It has a very organized internal structure that enables it to produce dangerous weather for pilots who encounter them. Updraft speeds may reach 9,000 feet per minute, so with wind speeds such as this, hazards are magnified and tornadoes are more likely to occur. This cell will also continue to form as long as the necessary ingredients are present. Hazards associated with thunderstorms. A thunderstorm can pack just about every aviation weather hazard into one vicious bundle. These hazards include lightning, adverse winds, downbursts, turbulence, icing, hail, rapid altimeter changes, static electricity, and of course, tornadoes. So, first is lightning. Lightning is a visible electrical discharge produced by a thunderstorm. The discharge may occur within or between clouds, between the cloud and air, or between a cloud and the ground. Lightning can damage or disable an aircraft. It can damage the skin of an aircraft or the communications and electrical navigation equipment of an aircraft. Adverse winds. When talking about adverse winds, I am referencing crosswinds, gusts, and wind shear. Adverse winds are always found within thunderstorms and are often many miles away from the precipitation area. Winds such as these can lead to a crash during takeoffs, approaches, and landings. Adverse winds are dangerous. You must be wary of them. Downbursts. Showers and thunderstorm cells often produce intense downdrafts, called downbursts, that create strong, often damaging winds. A downburst is especially dangerous to airplanes when it is encountered when climbing from takeoff or approaching to land due to them generally operating at relatively slow speeds. That's referencing the aircraft. The aircraft is operating at relatively slow speeds. Any major change in wind velocity could be fatal during these maneuvers. Next is turbulence. Turbulence is present in all thunderstorms. Severe turbulence is common. While gust loads can be severe enough to stall an aircraft at maneuvering speeds or cause structural damage at cruising speeds, turbulence is also very dangerous. Icing. Supercooled liquid water is abundant in thunderstorms. Supercooled water can exist at temperatures as cold as negative 40 degrees Celsius in the presence of vigorous upward vertical motion, such as in a thunderstorm updraft. Hail. Hail is precipitation in the form of balls or other irregular lumps of ice produced by thunderstorms. Hail is not uncommon during thunderstorms and has been measured to be up to 8 inches in diameter, 18.62 inches in circumference, and weigh up to 1.93 pounds. Very dangerous stuff. And lastly are tornadoes. Tornadoes are violently rotating columns of air in contact with the ground or water. If it's in contact with water, it is a waterspout though. But still classified as a tornado. They typically last only a few minutes and travel a few miles, but can persist for more than 90 minutes and track more than 100 miles in extreme cases. To wrap it all up, I wanted to say thank you for watching, and hopefully you are now able to understand the workings of a thunderstorm and the risks that are associated with it. Thunderstorms are works of art, painted without a canvas, but they are especially dangerous to aviators. Stay safe and happy holidays.